Today we're going to take a look at vertical translations of sine and cosine functions. Now you may remember from chapter 1 that if we added a constant to our function, that this shifted our entire graph up c units, but that if we subtracted, our graph would shift down c units. So we're going to take a look at sine and cosine functions that have been shifted up or shifted down. And here's our first example. We've got a cosine function, and we're going to start the same way that we did without the vertical translations. So our amplitude here is 3. Our frequency is 1 because the coefficient of x is 1, which means that the period is 2 pi. Now we're shifting up 1 unit. We can see this by the addition of that constant right there. So previously our graph would have had a range of -3 to 3. We know that from the amplitude. But now, since everything's being shifted up 1 unit, that range becomes -2 to 4. So same graph, except instead of being between -3 and 3, our graph will be between -2 and 4. So let's set up some axes. And label, let's go 1, 2, 3, 4. And -2. Now what I like to do is give myself a little dotted line in the middle that I use as a guide to help me graph my cosine function. So let's see. Cosine would have started here on the y-axis, but shifted up 1, so it's going to start up here. So that's our first point. And now we're going to draw 2 cycles starting here. We're going to go down to -2, back up to 4, down to -2, back up to 4. And our period is 2 pi, so we know 1 cycle here ends at 2 pi, and the second cycle would end at 4 pi. Let's fill a couple values in between. And here we have a cosine function, 2 cycles of a cosine function that have been shifted up 1 unit. All right, let's take a look at a sine function. Starting the same way, we're taking a look at the amplitude. And remember, the amplitude is the absolute value of the coefficient of your function. So we've got our amplitude is 5, our frequency is 2, right, this 2 over here, which means that our period is 2 pi over 2, which is equal to pi. Okay, so now let's take a look. We are adding a -2, or you can think of it as subtracting 2, which means that our entire graph will be shifting down 2 units. So our range would have gone from -5 to 5, but now the range is -7 to 3. So just subtracting 2 gives us -7 and +3. So here are our axes. Here's x and y. And now we want -7 and 3. Oops, not enough room. 6, 7. And 1, 2, 3. Okay. Now I like to draw my line halfway through. So halfway between 3 and -7 would be this -2 right here. So I like to draw that as a guide. and we're drawing a sine graph. So sine usually starts at the origin, but since it's shifted down 2 units, it's going to start at the point 0, -2. So here's my first point. I'm going to draw 2 sine curves, but I need to remember that I've got to go all the way up to 3 and all the way down to -7. Okay, here we go. 2 cycles, starting at -2, 1 cycle, 2 cycles. Okay, so our first cycle ends right here. So this, on our x-axis, would be equal to the period that is pi. And the second cycle, which goes from pi, so from here all the way to here, is our 2 pi. Remember to label the equation. And that's that. And here is our summary. You're going to start off the same exact way you did previously by finding your amplitude, frequency, and period. You're going to find the range based on the given amplitude and the value of C. You're going to start by labeling your x-axis to indicate the range, your highest value and your lowest value, and I highly recommend drawing a dotted line halfway in between those values to use as a guide. So now you go to step 4, which is just to draw your 2 cycles of sine or cosine. And then your final step is to label your x-axis using the period and then label with the equation of the function.